Hello, welcome. In this short video, let us look at an example illustrating how to calculate the different probabilities from a given probability distribution. In this short video, we will look at the exponential PDF. That is given the following probability distribution f of x equal to e power minus x for x greater than 0. Here clearly this is an exponential distribution with the parameter lambda is equal to 1. Given this PDF, our goal is to find different probabilities. That is the area under the PDF at different locations. For example, let us look at the probability of x greater than 1. It means we want to find the area that is between 1 and infinity. This is 0. So we want to find this area. So which is obviously given by probability of x greater than 1 is equal to integral 1 to infinity f of x dx. And by using the definition, this should be equal to 1 to infinity e power minus x dx. This integral of e power minus x is e power minus x by minus 1. We have minus of e power minus x. And the limits are 1 to infinity. Infinity, this value is 0. And at 1, this is e power minus 1. So we have minus of e power minus 1 by minus 1, which is e power minus 1. Therefore, probability of x greater than 1 is equal to e power minus, which is equal to 0.3679. So this is the area under this, the area of the shaded region is e power minus 1. That is probability of x per given PDF. Now let us look at the probability of an interval. It is given this distribution. We want to find the area under the curve between these 2 points, that is 1 and 2.5. So this should be equal to probability of 1 less than x less than 2.5 is equal to integral 1 to 2.5 of the probability density function, which is equal to integral 1 to 2.5 e power minus x dx. And again, since the integral is minus of e power minus x, the limits are 1 to 2.5. By inserting the limits, we get e power minus 1 minus e power minus 2.5, which should be equal to 0.2858. So this is the area between these two values. That is the area under the curve in this interval 1 to 2. Now let us look at the value of the probability distribution at x equal to 3. But since we are dealing with a continuous random variable, this should be equal to 3 to 3 fx of x dx. Since we are dealing with a continuous random variable, this should be equal to 0 because the limits are the same. The length of the interval is 0. So in other words, for continuous random variables, the probability of at any given value does not have any meaning, and it is usually assigned a 0 value. And next, we want to calculate the probability of x less than 4. That is the area under the curve from 0 to 4. So that is this region. So by definition, this should be equal to 0 to 4 fx of x or f of x dx. That is the PDF, the area under the PDF between 0 and 4, which is equal to integral 0 to 4 e power minus x dx. And this should be equal to minus e power minus x. Limits are 0 to 4. By inserting the values, we should get 1 minus e power minus. And this should be equal to 0.91. And finally, the probability of 3 less than or equal to x, which is also same as probability of x greater than or equal to 3, or is also 1 minus probability of x less than 3. This is also equal to probability of x less than 3. This is also equal to integral 3 to infinity f of x dx. That is equal to integral 3 to infinity e power minus x dx. And this is minus e power minus x. Limits are 3 to infinity. This should be equal to e power minus 3. Which is equal to 0.0498. Thus, we can calculate probabilities of different intervals given the PDF. Thanks for watching.